NENOMATICA, where mathematics meets YouTube excellence. In this video, we will factor the polynomial 4x to the fourth minus 5x squared y squared plus y to the fourth. We'll use smart grouping, recognition of a perfect square trinomial, and the difference of squares. Step 1. Rewrite by grouping terms. We will split the middle term into negative 4x squared y squared and negative 1x squared y squared. This lets us group a perfect square pattern. Step 2. Regroup terms. We will collect the first, the modified middle, and the last terms into a single trinomial, and then subtract x squared y squared. Step 3. Recognize the perfect square trinomial. The green trinomial matches the pattern A squared, minus 2ab plus b squared. Here, A equals 2x squared, and b equals y squared. So we can rewrite that trinomial as open parenthesis 2x squared close parenthesis squared, minus 2 times open parenthesis 2x squared close parenthesis times open parenthesis y squared close parenthesis plus open parenthesis y squared close parenthesis squared. The remaining term is still minus x squared y squared. Step 4. Write as a difference of squares. The first three terms form the square of a binomial, that is 2x squared minus y squared, all squared. And x squared y squared is the same as open parenthesis x y close parenthesis squared. So the expression becomes open parenthesis 2x squared minus y squared close parenthesis squared minus open parenthesis x y close parenthesis squared. Step 5. Apply the difference of squares formula. Use squared minus v squared factors as open parenthesis u minus v close parenthesis times open parenthesis u plus v close parenthesis. Substituting back u equals 2x squared minus y squared and v equals xy, we get the final factorization. We will factor the expression x to the fourth plus y to the fourth minus 11x squared y squared. Step 1. Group terms into a pair that can complete a perfect square. Step 2. Regroup so the first three terms form a perfect square trinomial. Step 3. Recognize the perfect square and rewrite as a square minus a square. Then, apply the difference of squares identity. Finally, write the factored form in clean binomial factors. Example 2. We will factor the expression x to the eighth plus x to the fourth plus 1. Step 1. Group terms to complete a square. Step 2. Regroup as a perfect square minus a fourth power. Step 3. Rewrite as a square minus a square to apply the identity. Step 4. Factor using the difference of squares identity. Step 5. Write the clean factored form. Here are the final answers consolidated. The first expression factors to left parenthesis x squared minus y squared minus 3xy, right parenthesis, times left parenthesis x squared minus y squared plus 3xy, right parenthesis. The second expression factors to left parenthesis x to the fourth minus x squared plus 1, right parenthesis, times left parenthesis, x to the fourth plus x squared plus 1, 5x to the fifth minus 5x times the quantity 25x squared minus 144. We'll first factor out 5x. That gives 5x times the quantity x to the fourth minus 25x squared plus 144. Now, we want to prepare a perfect square inside. Rewrite negative 25x squared as negative 24x squared minus x squared, so we can complete the square with x to the fourth minus 24x squared plus 12 squared. That chunk is a perfect square x squared minus 12, all squared. And then we still have the minus x squared. This sets us up for the difference of squares. A squared minus b squared equals left parenthesis, a minus b right parenthesis times left parenthesis, a plus b right parenthesis. Here, a is x squared minus 12, and b is x. So we factor to 5x times the two binomials x squared minus 12 minus x, and x squared minus 12 plus x. Now, simplify those two quadratics. We get x squared minus x minus 12, and x squared plus x minus 12. Each of those can be factored further. The first factors to x minus 4 times x plus 3, and the second factors to x plus 4 times x minus 3. So the complete factorization is 5x times x minus 4 times x plus 3 times x plus 4 times x minus 3. Quick visual check. Think of a squared minus b squared as two squares with sides a and b. Removing the smaller square area b squared from the larger a squared can be rearranged into a rectangle with sides a minus b and a plus b. That's why the factors are a minus b and a plus b. Example 2. Parenthesis x plus 1 close parenthesis squared minus 13x minus 61. We will regroup to see a quadratic in the expression x plus 1. Rewrite the constant as negative 13 minus 48, so that negative 13x can pair with the negative 13. Group as left bracket x plus 1 squared minus 13 times x plus 1, right bracket minus 48. Now treat u as x plus 1. Then we have u squared minus 13, u minus 48, which factors as u minus 16 times u plus 3. Substitute back u equals x plus 1 to get x plus 1 minus 16 times x plus 1 plus 3, which simplifies to x minus 15 times x plus 4. Problem statement: x to the fourth plus 4x squared y squared plus 16y to the fourth. Step 1. Group terms. We add and subtract a helpful middle term so we can set up a perfect square later. X to the fourth plus, open parenthesis, 8x squared minus 4x squared y squared, close parenthesis, plus 16y to the fourth. Step 2. Regroup. Collect the perfect square trinomial together. Open parenthesis, x squared to the second power plus 8x squared y squared plus 16y to the fourth, close parenthesis, minus 4x squared y squared. Step 3. Recognize the perfect square. The first group is the square of x squared plus 4y squared. Open parenthesis, x squared plus 4y squared, close parenthesis squared, minus 4x squared y squared. Step 4. Apply the difference of squares. A squared minus b squared equals open parenthesis, a minus b close parenthesis times open parenthesis, a plus b close parenthesis. Here, a is x squared plus 4y squared, and b is 2xy. So the factorization is open parenthesis x squared plus 4, y squared minus 2x, y close parenthesis times open parenthesis x squared plus 4, y squared plus 2x, y close parenthesis. Now, let's move to example 2 and follow the grouping structure step by step. Example 2. Problem statement: 11x squared plus 15x minus 14. Step 1. Group terms. We split the middle and first terms to prepare for factoring by grouping. Open parenthesis, 10x squared plus x squared, close parenthesis, plus open parenthesis, 20x minus 5x, close parenthesis, minus 14. Step 2. Regroup to pair like terms. Open parenthesis, 10x squared plus 20x, close parenthesis, plus open parenthesis, x squared minus 5x minus 14, close parenthesis. Step 3. Factor each group. 10x times x plus 2, plus x plus 2 times x minus 7. Notice the common binomial x plus 2 appears twice. Step 4. Factor out the common binomial x plus 2 times open parenthesis 10x plus x minus 7, close parenthesis. Step 5. Combine like terms inside the second factor. We get x plus 2 times 11x minus 7. Final answers. In this lesson, we will factor the polynomial x to the fourth plus 4x minus 1, following a decomposition and regrouping strategy. We will carefully mirror the step order. Rewrite by grouping, regroup, recognize perfect squares, apply the difference of squares, and then simplify factors. Step 1. Rewrite by grouping terms. To create helpful perfect squares, we add and subtract the same expressions, 2x squared and 1. This keeps the value the same while allowing structure to appear. Here is the rewrite. Step 2. Regroup. We collect terms into two parentheses, where the first group is x to the fourth plus 2x squared plus 1, and the second group is 2x squared minus 4x plus 2. Notice the subtraction in front of the second group. Step 3. Recognize perfect squares. The first group, x to the fourth plus 2x squared plus 1, is the square of x squared plus 1 squared plus 1. The second group, 2x squared minus 4x plus 2, is 2 times the square of x minus 1. We write these identities and then express the whole expression as a difference of squares. Step 4. Apply the difference of squares. Think of this as a squared minus b squared, which equals a plus b times a minus b. Here a is x squared plus 1, and b is square root of 2 times x minus 1. factor using a plus b and a minus b. Step 5. Simplify each factor by distributing the square root of 2. This turns the factors into simple quadratic trinomials. Therefore, the final factorization is the product of these two quadratics. As a quick challenge, we will solve the algebraic proof step by step following the exact structure shown. Given a squared minus 2, b squared minus ab equals 0, with a and b greater than 0, we will prove that it equals 2b. Step 1. Rearrange the expression by grouping so that we see two natural factors. We group a squared minus b squared and subtract the group b squared plus ab. This keeps the expression exactly the same, just reorganized. Now highlight the two groups we intend to factor. Step 2. Factor each group. The first group is a difference of squares, which factors as left parenthesis a minus b right parenthesis times left parenthesis a plus b right parenthesis. The second group factors by taking out b as a common factor, giving b times left parenthesis b plus a right parenthesis. Keep the subtraction sign between the groups. Step 3. Notice that both terms share the common factor a plus b. Factor a plus b out using the distributive property. That yields left parenthesis a plus b right parenthesis times left parenthesis a minus b right parenthesis equals 0. Combine like terms inside to get left parenthesis a plus b right parenthesis times left parenthesis a minus 2b right parenthesis equals 0. Highlight the common factor a plus b. Step 4. Apply the zero product property. If a product equals 0, at least one factor must be 0. We have a plus b times a minus 2b equals 0. Because a and b are both strictly positive, the sum of plus b is strictly positive and cannot be 0. Therefore, the only possibility is a minus 2b equals 0, which gives it equals 2b. Final result, a equals 2b. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.